I'm pretty sure that's what I got.
Alright. Okay, today, here's what we're going to do. We're going to do just a few problems today where we talk about slope. We have two postulates today, 3-2 and 3-3 today. My goal is to just do a couple examples, then we're done today. Make sense? Okay, now, if you did not turn in homework on Friday, that was the page 183. That is technically late now. So make sure that you are getting that turned in case you were gone. Okay, alright. So take out your notes. You'll need them right now. Alright. Okay, let's go through a couple examples of slope today. So I'm going to put my graph up here on the board like we did Friday. We'll go through just a few examples of, how to graph, how to find slope. You guys seem pretty good on that. But I want to do some of those rare cases that we saw. We've done positive and negative slope in this class, but like the zero slope or undefined slope, I want to make sure that we understand that. Okay? So I want to make sure that we cover those two for sure. Let me put a graph here on the board. All right. Okay. So here's my graph. Let's say we're going to find slope of. Let's just do a normal problem. So something like -4, 6, that'll be letter A, and letter B will be, say it again? 2, 7? Yeah, 2, 7. So let's say that this is our coordinates, right? And we want to find the slope of that individual line. It's a unique line that hits both of those coordinates, right? So -4, 7, this is the x numbers, these are the y numbers. They always go alphabetical order. Remember, you have to pick the elevator before you go to the floor. So elevators are right and left. So I'm picking the -4th elevator going to the 6th floor. Right there. There's letter A. Letter B is 2, 7, so 2 over, 7 up. There's B. And we could draw the line in there if you want. I know that eventually when we get work on this section, you will have to graph quite a few of them. Where they're going to give you coordinates, they're going to ask you to graph, and then find slope after you do that. So I will provide you graph paper so you know that. But again, hopefully everyone's getting the majority of these correct. Pretty straightforward how to graph those. All right, so there's my slope. Again, most people, they can count with their fingers, rise over run. Just use the formula. You won't get it wrong. You won't count wrong. You won't be off. You won't have to really focus really hard at what marker you're looking at or counting. But the simple formula to find slope, if you don't remember it, remember it's called the rate of change. It's how it's changing as you go from left to right side. That's what's happening. So this is the formula that we have. We subtract the y numbers on the top. You put the x numbers on the bottom, and typically what they call it rise over run. That's like the typical term that most people use in algebra class. Why they call it that is because you're finding the difference in the y numbers. That's rising. That's what you're doing. And then the running is going left to right. That's your x numbers. I know in some textbooks they refer to it as this. Delta y over delta x. Delta is a Greek term that stands for change. Change in y's, change in x's. Some algebra classes do that. It's not a big deal. I just want you to know the different names you can call this. So typically I like this one. It makes sense to me. I'm looking for the simple fraction. It can be a whole number, don't get me wrong, but I'm just looking for a fraction. What I'm looking for. So my y numbers, 6 and 7. It doesn't matter the order you subtract as long as you stick with that order that you started with. So like me personally, when I always have these, I always just do top minus bottom. It makes no difference. That's the way I've always just kind of done it, so I guarantee you get the correct answer. So the y numbers are 6 and 7. So 6 is on the top, so 6 minus 7. Then on the bottom, top minus bottom is -4 minus 2. whatever those numbers are, you subtract them. So, you know, if that's a negative number, then I'm taking -4 minus -2, whatever that is. Okay? All right. 6 minus 7, what do we get? -1. Thank you. All right. And -4 minus 2 more? -6. The negative signs cancel. I don't know if we talked about that last week. When you have negatives top and bottom like this, they do cancel out. So it makes a positive. That just works for fractions. So this is actually a positive 1/6. So that is a positive slope. This is the way that the negative sign cancels. So that means that I'm rising 1 for every sixth, or I'm rising 1 for every sixth that I run to the right. I'm going up to the right, always to the right. Okay. Questions, comments about slope right now? All right, let's do one more. Then I want to get to these special properties about slope themselves, so that we can go into our new topic. So I have a couple of examples about that. But let's just do one more. I want to hit one of those rare cases. Let's go with the coordinates. Coordinate for, let's call this C, let's call this, so 6, 1, and D is going to be 6, -5. Okay, so let's say those are my coordinates, and this is going to be one of those rare cases. So first thing I always like to do is graph it, see where it's going here. So 6, 1, 1, 2, 3, 4, 5, 6, 1, so through C. 6, -5, 1, 2, 3, 4, 5. Again, how I'm doing that, always start at the origin and then graph them. That's letter D. And the line that connects them. Okay, there's my line. What type of line is that? Definitely undefined like what we talked about Friday, but it's called vertical line. Okay, it's a vertical line. We definitely talked about slope Friday. It is an undefined slope. I want to discuss why. It's one of those rare cases. It's not going up to the right, so it's definitely not positive slope. It's not negative slope. It was that rare case. This is like the most extreme one. It's the one that doesn't make any sense for a business model. Because you're not losing or gaining money. You're not staying flat. It's just a rare case that doesn't work. It's undefined. Because the way that the numbers actually fit the formula, that's why it works, okay? Or why it turns out the way it does. All right. So subtracting the actual numbers. Remember, these are my x and y's. So I'm going to subtract the y's on the top. So 1 minus the -5. 1 minus the negative. The two negative signs will cancel better. Then on the bottom, I have 6 minus 6. Remember, y's on the top, x on the bottom. For some reason, some people really struggle with that concept. All right, so this turns out to be 1 plus 5. The two negative signs cancel out. And I think 6 on the top, and then the bottom, 6 minus 6 is 0. And that's why this is undefined slope. And I want you to call it that from now on. It's called undefined. I know it's a vertical line. I mean, that's the whole point. But the idea is that it's undefined. It doesn't work. You cannot divide by 0. The way that I always try to explain it, when you're dividing, you're trying to break like a larger number into smaller parts, right? That's usually what division's for, smaller pieces. You have 6 cookies, and you're dividing into 0 friends. That doesn't make any sense. Okay, why would you be dividing into 0? I mean, there's no purpose in doing that. Okay, there's no number for that. And this is the drawing. Okay, any questions about the rare case? That's like one of the most extreme cases. Then the other one we had yesterday or Friday was the horizontal line. That's a 0 slope. This is the top number return to be 0. But everyone understand why that's undefined? Because you can't divide by 0. That's why that's what they named it. Okay. That was just kind of a quick, brief review of kind of what we did Friday. If you were gone, the video was online. I think it was online Saturday morning or something like that. All right. I want to talk about 2 postulates today. We're going to deal with our main topic that I think I I briefly introed last Thursday, but we never really came back to it. Really spent Friday kind of reviewing, trying to find slope, different pictures, but we never came back to a simple topic that the whole point of doing this, and we never came back to it. So I want to talk about these postulates. In fact, I'm going to just put them over here. Okay. So, the property I want to talk about, this is postulate 3.2. Two non-vertical lines have the same slope if and only if they are parallel. So two non-vertical lines have the same slope if and only if they are parallel. And then the book does this thing where it recaps, it puts in quotes, parallel lines have the same slope. Equal slope, congruent slope, whatever you want to call it. They also have this other like side note that says vertical lines are always parallel. Makes sense. Also, horizontal lines are always parallel. I don't know why they didn't say both, but they say for non-vertical lines, the ones that are like tough to look at. Okay, now it's a postulate, correct? We don't prove postulates. Okay, we don't prove postulates. It's something we take for granted. We actually use this. Okay, I'm going to give an example of it, just so you can see it. The idea of parallel. Today. In fact, I'm going to do one of the examples that you'll see in the book, so you know like how we're going to use this. Any questions with the postulate, though? Everybody have it written down? Yeah. Postulate, we don't prove it. Okay, so here's the type of example that you see like in a homework, like how we're going to use this. It'd be something like this. Find the point that satisfies following problem. Okay, so they want you to find like a certain coordinate, a certain ordered pair that will answer the following question. A line passes through E 4, 7 and is parallel to line G, which is 1, 5, and H, which would be 7, -1. Okay, so how this one works, they're giving you, they want you to find a point that will make this thing work. So a line is passing through E 4, 7, right? So I'm going to draw E right now. So E is 4, 7. So here's 4, 1, 2, 3, 4, 5, 6, 7. So here's E, right? And that line is parallel. So there is some magical line. So I'm going to draw a hypothetical here. There's some magical line that is passing through E like this. And it's at some weird tilt, right? And I want to be parallel to the line that goes through G, which is 1 comma 5. 1, 2, 3, 4, 5. So that's G. And H, which is 7 comma negative 1. 1, 2, 3, 4, 5, 6, 7, negative 1. And here's H. And so there's a line that's going through those two. Okay, makes sense? Like what we're doing here. Now, we're just trying to find a single point. So that means that there's an infinite number of possibilities here. Okay, there's an infinite number, but we are trying to find a random dot here. It's, it's somewhere here or here, or somewhere on the line, where E is, that will make it perfectly parallel to GH's line. So this line has a very particular slope. It's a certain number. This line also has to have the same slope according to the postulate we just learned. If they're going to be parallel, they have to have the same slope. So in fact, what I need to do first, figure out what the slope is of GH. So I'm going to do that right now. So GH is, so here's G, it's 1 comma 5, and H is, what is that, 7, negative 1. All right, so the first thing I'm going to do, I need to find that slope. So the slope of that line is, I need to subtract the y number, so 5 minus the negative 1. I need to subtract the x number, so 1 minus 7. And this turns out to be 6 over negative 6, which is negative 1 over 1 if I simplify. Or 1 over negative 1. However, it doesn't matter where you put the negative sign. Okay, questions with how I just set that up? Okay, so now the idea is that I need to find another coordinate that will be on this line right here that will have the same slope. Here's the shortcut. What does slope stand for? Like what does slope mean? Rise over run, okay? Rise over run. Now I don't know why, I always put the negative sign on top, because rising and running makes sense, like I'm either dropping or going up and down. So that's what rise means to me. And then running is always going to the right. So if this is telling me that I'm dropping 1 or running 1 from right here, dropping 1, running 1, what is this coordinate right here? What is that spot right there? 5 comma 6, right? That's 5 comma 6. Because I'm dropping 1 here, running 1. So if I count over 5, go up 6. That's the point that I wanted. This answers the question. Like, that's how easy it is. You use slope, and you find the next dot on the line. So I start at E, and I just use slope, because it tells me how far to rise and run from that dot E. Because now, if I actually find slope here, so here's E. E was, what is that, 4 comma 7. And we just found that mystery point, which was 5 comma 6. This will have the same slope as that thing. I just made sure of it, because the way that I use slope to actually drop and run by the same digits, by using this simplified version. So if I actually subtract these, 7 minus 6, 4 minus the negative, or 4 minus the 5, I get 1 over negative 1, which is the same slope. You see that? Like, that's how easy it is. You just use slope and use the dot that's on the line. Okay, let's do another one. Same exact idea so that you can get kind of a feel for it. Okay? So somebody give me a random dot to go through. Say it again? Okay. All right. So this would be my letter. This would be my point x. 1, negative 7. Okay. Now give me 2 other coordinates. That'll be the other line. There'll be some mystery line that we need to be parallel to. Okay. So hold on. Say it again. So 8, negative 3. Okay. That'll be y coordinate. And give me another coordinate to go through. All right, so I want to be on this line that's passing through 1, negative 7. So here's 1, negative 7, 1, 2, 3, 4, 5, 6, 7. Okay, here's point X. There's some mystery line that's going through X. That's all we know. And it's going to be parallel to YZ. YZ's line is going through YZ line is going through the 8, -3. So here's 8, -3. There's Y, and Z is -6, 5, 4, 5, 6, 5. 1, 2, 3, 4, 5. All right, here's Z. Okay, and there's some mystery line going through there. Okay, so we need to be parallel to that thing. So there's a line passing through X, and it's parallel to this thing. And I need to find another dot on here. Find a point that's on this line that's parallel to that one. That's the whole goal of this problem. That's what you're trying to find. Okay, since it's parallel, I have to have the same slope. So the first thing I'm going to find slope of line YZ. Because I can see that line right there. Let's find the slope of it. So I always write the coordinates down. So Z's coordinates are -6, 5. It doesn't matter that we're writing them as long as I have them written down. Okay, so that's 6, 5. And my other one, what is that? 8, -3. That's Y and Z. Let's subtract the numbers to find slope. So my slope is 5 minus the -3 over -6 minus the 8. And I get, this simplifies to make 8. And this makes -14. And I'll simplify that fraction. So I think they both have 2's in common. So I take out a 2, that's a 4 over 7. And it doesn't matter where you put the negative sign, I'll just put it on the top. Okay, so that means that's my slope. That's my rise over run number. So that means to find the next dot, I'm going to drop 4, run 7, and I always go to the right. Okay, so I'm going to drop 4 from here. 1, 2, 3, 4, and run 7. 1, 2, 3, 4, 5, 6, 7. There's that mystery point that I need to find. This will make the line perfectly parallel. That's what it's going to do. It's going to make it perfectly parallel. But that coordinate, if I drop 4, run 7, that coordinate is going to be 8, -11. That'll be my mystery point. Because again, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and then dropping 11 straight down. Because this is 12, so that's 11. This is the whole goal. Find those mystery coordinates that make it work. Okay, does everyone see how I'm using slope to do that? And I'm just counting with my fingers where that's dotted. Okay, that's what you're going to have to do in the homework eventually tomorrow. So I'll give you things where you have to graph it like this. So this is the type of problem. So you have to graph, to find that mystery coordinate. There's an infinite number of them I could have found. I could have went further. I could have went this direction, going back to 7 and up to 4, that type of thing. Okay, any questions, comments, concerns about 3-2, the actual postulate we just did? Okay, now comes the hard part. Because so far, these have been fairly easy. Yeah, the parallel lines are simple, they have the same slope, really nothing difficult about them. Just, knowing how to graph and find coordinates. Some people are like terrible at graphing. You need to get better at it. So this is something you can't get away with. Okay, now comes the tough part. We need to do postulate 3-3. This is very, very, very difficult. Okay, postulate 3.3. If two non-vertical lines have a slope whose products are -1, then the line non-vertical lines have slope whose product is -1, then the lines are perpendicular. Now, what does perpendicular mean? What do we remember? We've had it in every chapter test up till this point, 90 degrees. So the things are hitting at like right angles. Okay, so what they're saying is that their product is -1. What it means by product, this keyword here, the word product in algebra means you multiply. So we're going to multiply slopes together, and they're going to give me a -1 out of it. Okay, what I mean by -1, this is the idea. -3/4 times 4/3. When I multiply these two slopes, let's say those are the slopes in my lines. What I'm going to get here is I'm going to get -1, because the idea is that when you multiply fractions together, you can simplify up and down if you can, or you can simplify diagonally. Well, they have 3's in common, so I divide both of these by 3, I get 1 and 1. These both have 4's in common, so I divide them both by 4's, so that's 1 and 1. And now I can multiply straight across. That's how multiplying fractions work. So -1 times 1 is -1. 1 times 1 is 1, and that is the number -1. So those two slopes are perpendicular to each other if I look at the lines that have those particular slopes. And that, let me draw two lines that would have those types of slopes. So -3/4 and 4/3. Let me draw two lines just so you can see this, and I will put like a protractor on the board so you can see that it is 90 degrees. It is perpendicular. Okay, so let me give you a coordinate here. Let's call this 2, 3. There's 2, 3, and let's drop 3, run 4. There's B, that is 1, 2, 3, 4, 5. So it's 5 times 0. 5 times 0, and 2 times 3. Or 1. Alright, so that slope is dropping 3, running 4. So A is 1 times 3, B is 5, 0. And I just want to prove the fact that it is negative. When I actually find the slope of this line, subtract the y numbers, subtract the x numbers, I do get 3/-4, which is -3/4. It doesn't matter where you put the negative sign. So it is dropping 3, running 4. And now I'm going to create another line that is going to complete different direction perpendicular to that by using just the slope to figure that out. So there we go. There's the first line. I'll draw the second line in red. You can see this. Okay, so now I just need two coordinates that will have a slope that is the complete flip of that. So 4/3. So I'll pick another coordinate. I'll put it over here. So it was -3, -4. -3, -4. Let's call this C. And I need to rise 4, run 3. Rise 4, run 3. So that's 0, 0. That'll be my letter D. If I draw it, when I draw this line, you'll see it. So they're hitting at some random spot. I don't really care where they hit, where they intersect. That's an algebra 1, algebra 2 topic. But I do want to show you that their slopes are their products are -1, which I showed you over there, but I do need to prove C and D here. So C is -3, -4. D is 0, 0. If I actually subtract these, -4 minus 0, -3 minus 0, and that turns out to be -4/-3, which makes sense cancel. Okay, so these are the slopes, my two lines I just showed you over there, that they do make -1 when you multiply them together. But I do want to show you that it is a perpendicular line, that they do make 90 degrees. So protractor really big, 90 degrees is right at the top, so I'm going to try to make a perfect L shape. So I'll just kind of measure this. I'm going to put the arrow right here, make this line follow 0. So it's following 0 right around there, and I can count up 10, 20, 30, 40, 50, up till 90. And if I actually line this up correctly, it does make perfectly 90. That's the idea. It's a perfect 90-degree shape. Because that's what the postulate says. That when the products work out to be perfectly perpendicular, or when the products of their slopes make -1, then the lines have to be perpendicular, 90 degrees to each other. Now, what you probably talked about in Algebra 1, long time ago, there's a certain name for this, how the slopes are changed. Okay, so let me go back to the original problem here, so you can see this. -3/4 and 4/3. How are these two related? There's a name for it. Say it. It's called a reciprocal. Yeah, it's a perfect reciprocal. In fact, it's called an opposite reciprocal. That's the term that they use in Algebra 1. Okay. They're opposites in sign, one's positive, one's negative, and then the reciprocals, they're splits of each other. That's how it works. Okay, make sense? And what your homework would eventually look like tomorrow, they'll do the same type of problem I just did a little bit ago, where they're going to say, okay, you need a line going through, 1, -7, and it needs to be perpendicular to this other line. So in fact, I'm going to do this problem. This is going to be my last problem today. Last problem today. Okay, so same exact idea, but now we're doing the perpendicular idea. We're doing the same instructions. Find a certain coordinate that makes this line work perfectly. I want to be perpendicular to YZ. I'm going to draw YZ first. So 8, -3. There's Y. Z is -6, 5, 4, 5, 6. 1, 2, 3, 4, 5. All right, so there's Z. So line connects them. So here's YZ. Okay, so there's YZ. And I need to pass through 1, -7. 1, 2, 3, 4, 5, 6, 7. So there's X. And I need to be perpendicular to this line YZ. So first thing I need to do is figure out the slope. And then I'm going to do the opposite reciprocal like we just talked about a little bit ago. Okay, so the slope of YZ, so here's Z, that is -6, 5. And Y is 8, -3. Okay, the slope is 5 minus -3 over -6 minus 8, which we just said a little bit ago was 8 over -14, which is 4, -4 over 7 if I divide them both by 2. So that means it's dropping 4, running 7. So my slope that I need, right, the slope that I need for my line has to be the opposite reciprocal. Okay, so that's what we just talked about. That's the way that the products would actually work out. So my slope for this line that needs to be perpendicular needs to be the flip of that, so 7/4, and it has to be positive. This is the slope that will be perpendicular. So it means I'm going to rise 7, run 4 to the right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. That coordinate right there, which is 5, 0. That's the coordinate. We call that the mystery point P. That makes my lines perfectly perpendicular. 90 degrees. Again, how I did that, I used my slope from this dot right here to figure out that mystery dot. Okay. Questions, comments on anything I've talked about today? Okay, tomorrow, for sure. We're going to do a few examples of these. I'll pick a couple problems from the book. I'll let you guys maybe pick a problem or two from the book, so maybe you get a homework assignment, you get a homework problem or whatnot. But tomorrow we are most definitely getting homework. So make sure you bring your books tomorrow. Try to bring in your actual hardcover book for once. I want to do a book check tomorrow to make sure you have the right book number. I try to do it once a quarter to make sure you're not losing the book. You still have the right book number. I still look for book covers, that type of thing. So if your book cover is disintegrated by now, try to get one on there, that type of thing. Okay? So, tomorrow, book. Make sure you got a book cover on it still, and we're going to get home. So remember, we're at the elementary. Okay. Rachel, remember, we're at the elementary building tonight.
Yeah, for like outfitting, yeah.
Sadie, same thing, elementary building tonight.
Is he gonna go late?
I don't think so. We won't need to go super late since we're starting at 3:30. So I'm hoping we don't have a 3-hour practice.
We better never mind. We're gonna have a 3-hour practice. Sadie, you were so crazy that time. Everybody was mad at her in that practice. Except for me, because I don't know what's happening.
Yeah, there's some weird attitudes out there.
Wow, Mr. Ward, that drawing is so good.
I'll have to put it up there.
It's gorgeous.
It is.
I asked him on the bus Friday. I was like, dude, you need a drawing up? He was like, yep. It's gorgeous. Whoever drew it is probably needs to get that like 40 and something like that. Studio because that's gorgeous. Probably not. It really brings out his eyebrows is it really brings out your eyebrows. Or your mustache. Actually, why do I make the mustache so straight? I don't think it kind of looks creepy. Yeah, I know. Should I go erase it?
No, you're not allowed to touch it. It's already hung.
Oh! But I drew it! And didn't mean to make it so straight. See, in my little picture you kind of went. Yeah, in the little picture I didn't. Then I got to the big picture and he's like here. I'm gonna sneak in here sometime and I'm gonna fix it. Come in here for the period and change it. Oh, that's cute.
No, peek.
It really brings out his eyebrows, right? No,
Oh, yeah.
On the bigger one? Yeah, they were. On the big one, that mustache really shiny. I have biology. The little one was really good. I love
Very
it.
peaky.
Oh.
You're either A, ready for any sport that you're at after school, or you're kind of relaxing.
Rachel.
Well, I think at this point, you want you to know you can go to the shower.
Holden Larson, Parker Schneiders. Please come to the office, Holden Larson and Parker Schneiders.
Yeah, they're gone.
Hello?
Where?
Whoa.
I didn't even recognize you. Thanks.
That's a cool do.
It's better than Stu's do. Stu got triggered last night.
No, he poured Dr. Pepper all over my car. And it froze to it. I think it makes